According to Kimberly Cartier on EOS, our solar system is encased in a bubble, the heliosphere, that protects from interstellar winds that move through the galaxy. This massive, invisible shield, powered by the solar system, stretches miles beyond Pluto. I'll explain how the solar wind bubble protects our planets, how the heliopause forms a balance with interstellar space, and how the heliosphere is always shifting. By understanding this hidden shield, we can better appreciate how the sun shapes our space environment and makes exploration beyond Earth possible. Understanding the solar wind and the heliosphere isn't just about curiosity, it's about survival, exploration, and unlocking the secrets of space. The solar wind bubble protects us from the galaxy's high energy radiation. The solar wind is a stream of charged particles ejected from the sun's upper atmosphere. This stream forms the heliosphere, which acts as a protective bubble against harmful cosmic radiation. NASA's IBX mission mapped active neutral atoms that outline the protective bubble. Computers model shows how correlations between solar activity and the strength of the heliosphere shielding effects. According to NASA, Voyager 1 and its twin Voyager 2 are the only spacecraft ever to operate outside the heliosphere, the protective bubble of particles and magnetic fields generated by the sun. The heliosphere's dynamic response to solar activity, adapting shield strengths needed. Now we have explored the solar wind bubble and how it protects. Let's look at where it ends and what lies beyond. Let's turn to the heliopause, the boundary where the sun influences give way to the interstellar medium. The heliopause creates balance between the solar wind and the interstellar wind. The heliopause marks the outer boundary of the heliosphere, where the sun's solar wind pressure balances the interstellar medium pressure. According to EOS site, Voyager 1 in 2012 recorded abrupt shifts in large particle density and magnetic field directions upon crossing it. Voyager 2 in 2018 confirmed the balance point with similar observations of solar galactic particles changing. Science Trek notes the balance, regulation, interstellar radiation, and material entering the solar system. Now that we understand how the heliopause differs from the sun's boundary with the interstellar space, let's explore why the heliopause shape is far beyond uniform. The heliopause is asymmetrical. In observation shown by the heliosphere, it is not a perfect sphere, but is distorted with an asymmetrical shape by the interstellar magnetic field and the solar wind motion through the galaxy. While the heliosphere develops the solar system, the size of the shape varied by direction. IBX data revealed a ribbon-like feature indicating compression in some regions. According to NASA IBX, NASA reports the heliosphere is a comet-like tail stretching thousands of astronomical units. If the interstellar magnetic field and motion distort the solar wind bubble, heliosphere shape would be uneven rather than spherical. But models confirm the compressed nose of the extended tail structure. This dynamic shape affects the spacecraft navigation and radiation exposure forecasts. Now we talked about the solar wind bubble and the heliosphere is our solar system's line of first defense. The vast shield protects every planet, spacecraft, and all of us from galaxy harsh radiation. From the heliopause boundary to the shifting shape, the heliosphere shows how closely tied we are to the sun. Without the Earth, it would be far greater cosmic rays. As we explore Mars and beyond, let's remember that understanding and protecting the invisible bubble is essential to our survival and future in space.